Congratulations on hitting the end of this chapter. This chapter was all about templates. And we have seen that templates are a mechanism we have to set up function blueprints in our code. The main thing we saw that they solve is code repetition. We don't have to set up multiple overloads of the same function if the logic we really are doing inside is the same. We don't have to do something like this. What we can do instead is set up a function template, which is going to be one point of control for this function in our code. And the compiler is going to use this to generate our template instances when we issue function calls to this function template here. We have learned about a lot in this topic. You had a chance to set up your own function template. After that, we looked at template type deduction and how you can set up explicit template arguments for your function templates. We looked at how we could pass function template parameters by reference, and you can do this if it makes sense for your application. We had a chance to look at how we could do template specialization and make the compiler choose our specialization if it makes sense for whatever it is we are doing. We had a chance to do some analysis on how the compiler chooses the best fitting function to call if you happen to have overloads and specializations in your code. After that, we looked at multiple template parameters. We saw that you could do this if you need that in your application. We looked at return type deduction with templates. We saw that we could do that either through auto, we could do that through decal type and trailing return types. We could even do that through decal type and auto. And these three ways of doing things have differences. For example, with auto here and decal type auto, we don't have the ability to split our function into declaration and definition. But if we use trailing return types, we're going to be able to do that. And we saw that we could do this in this chapter. After that, we looked at default arguments, and you can use this if it helps your design. We looked at non-type template parameters. We saw that we could use values as template parameters and not use types like we have been using all along in this chapter. We saw that we have a nicer syntax to do function templates using auto. And if you do this, the compiler is going to generate a function template behind the scenes. We saw that we could name our template parameters in Lambda functions and make it possible to constrain how our Lambda function works. We saw, for example, that we could constrain for the function to have the same types, and we could even go further and use type traits and constrain really what users can pass to our function. We had a chance to look at type traits and static asserts, and this could allow us to do some compile time checks. And we closed the chapter by looking at constexprf, a mechanism we have to do branching or conditional checks at compile time. And this is really cool in that the branches that are not used by your function call are going to be discarded by the compiler, and your template instance will only include what you need. This is really all I had to share in this chapter. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to start and learn about concepts. Go ahead and finish up here and meet me there.